Hey guys, Miss Fearing here, bringing you Unit 8, Notes 3. Today we're going to go ahead and we're going to multiply radical expressions. So yesterday we went through and we added and subtracted. We're going to follow something a little bit similar to that, but we're going to multiply this time. So multiplying radical expressions, here's our rules. Step 1, we want to multiply the outsides of the radical. Step 2, we multiply underneath the radical, and then step 3, we simplify the remaining expression just like we did on day 1 and yesterday. So how does this actually look? Let's look at this first example here. We have the square root of 2 times the square root of 5. Well, we know that there are imaginary 1s in front of both of these, so we would multiply 1 times 1, which is still 1, and then the square root of 2 times the square root of 5 is going to give me the square root of 10. Before I can be done, I want to go ahead and look at this and say, can I simplify the square root of 10? Well, we are going to look for those perfect squares that go into it and see if any of them go in evenly. So my perfect squares are, start with the highest to the lowest. I'm going to start with 9. 9 doesn't go in. 4 doesn't go in. 1 doesn't go in. So nothing can be simplified out of the square root of 10. So I'm just going to go ahead and leave this as the square root of 10, and that's going to be my final answer. So number 2, we're going to simplify by multiplying the outsides. So 6 times 4 is going to give me 24. And then multiply the radicals. So square root of 3 times square root of 2 is going to give me square root of 6. I cannot simplify square root of 6. There are no perfect squares that go into it. So this is going to be my final answer, and I'm done. Let's look at example number 3 here. We're going to multiply 3 different things. Now I have 2 root 3 times root 2 times 4 root 3. So I'm going to go ahead and I'm still going to multiply everything on the outside. So I have 2 times 4, which is going to give me 8. And then multiply everything underneath. So I have 3 times 2, which is 6 times 3, which is going to give me 18. So now I'm going to go ahead and I'm going to try to simplify the root if I possibly can. Well, in this case, I can. I can split this up into square root of 9 and square root of 2. I'm still going to have that 8 out front. So go one step further. Now I have 8. Square root of 9 is 3. Square root of 2 is a decimal, so we're going to leave that. 8 times 3 then is 24. Root 2. That's my simplified answer, and I'm done. So number 4 then, multiply the outsides. So negative 6 and negative 4, I get negative 24. Multiply underneath. So I get the square root of 5 times the square root of 15. I'm going to get the square root of 75. We want to go ahead and we want to simplify 75 then. So I can split this up into be the square root of 25 and the square root of 3. I still have that negative 24 out front. So I'm going to go one step further. I have the negative 24. Square root of 25 is just 5. Square root of 3 is still going to be square root of 3. Negative 24 times 5 is negative 120, and I have the root 3. So now I'm going to go ahead and I'm going to put variables underneath, and it's still going to be the same idea. You just have to determine, remember, what happens when you multiply variables. What do we do with those powers? Remember, we add them, and if there isn't one, it's an imaginary 1. So that always comes back to us. We don't want to forget that. So we're going to multiply everything underneath the root. So I'm going to do 20 times 6 first, and I get 120. X squared times x is going to give me x to the third. So remember, we're going to split this up into the square root of 120, and then the square root of x times x times x. So we're going to deal with the square root of 120 first. I'm going to go ahead and I know that the only perfect square that goes into 120 is going to be 4. So we're going to split this up into the square root of 4 and the square root of 30. So I'm going to have 2 root 30 for this. And now simplify my variables. Remember, my variables need pairs in order for them to come out front. So that's going to be an x. And I'm going to be left with 1x underneath the root. So I'm going to put these two together by putting the things outside together and the things underneath together. So I'm doing 2x, and then underneath I'll have 30x. So my final answer is 2x root 30x. So we're going to do the same thing with number 6 here. We're going to multiply things out front. So I have 1 times 4 is going to give me 4. Multiply the things underneath. So I have 18 times 3 is 54. And then a squared times a squared is going to give me a to the fourth power, because remember we want to add those things, so a to the fourth. So now I'm going to split that up even further. I get 4, I want the root 54, and then root a times a times a times a. So I'm going to deal with the root 54 first, looking for a perfect square that goes into that. I can split it into root 9 and root 6. So I get 4 times 3 root 6. 4 times 3 is 12 root 6. Now I'm going to go back and I'm going to deal with those a's. Well, they need groups to come out, so pairs to come out front. So I'm going to be left with a times a, and I don't have anything underneath the radical then anymore. So one step further, I get a times a, which is a squared. And now we're going to put these two together again. So anything that's underneath the radical stays underneath. Anything that's out goes out front. So I'm going to get 12a squared. And then I still have the root 6 as my final answer. So now we're going to go ahead and we're going to look at a couple that are just written out a different way. So when we see this, we know that anything times a group in parentheses is our distributive property. It's the same idea. We're still multiplying these things through. So I'm doing the square root of 3 times the square root of 5, which is going to give me root 15, minus square root of 3 times 4. Well, 4 is not underneath a root, so I can't multiply that by the root 3. So that has to stay out front. So it's going to be 4 root 3. I'm going to ask myself, can I simplify the square root of 15? Any perfect squares that go into that? I cannot. So this is going to be my final answer, and I'm done. Same idea for number 8. We're going to distribute this through. So anything that's not underneath the radical, we can multiply. So I can multiply the negative 3 times the 2, which is going to give me negative 6. I still have root 3 for that first one. Plus, negative 3 times a 1 is going to give me a negative 3. Square root of 3 times square root of 6 is square root of 18. So we're going to go through and we are going to try to simplify this. I cannot simplify root 3, so I'm going to leave this as negative 6 root 3. But I can simplify plus a negative, we're just saying a minus. I can simplify that 18 into square root of 9 and square root of 2. So even further, I get negative 3 square root of 9 is 3. Root 2 is going to be a decimal, we'll leave it that way. I only want one number out front, so we're going to multiply those together. So I'm going to get 9 root 2. And now we're going to think back to our adding and subtracting. Remember, when we add and subtract, the things underneath the root have to be the same. And since one's a root 3 and one's a root 2, this is going to be my final answer, and I will be done. So number 9 here, again, we're going to multiply and distribute this through, but we have variables that we're dealing with, so just kind of keep in mind what we do with our variables. Multiply the numbers out front, or things not under a radical. Well, there is an imaginary 1 times 3, so I get 3 root 14x minus no numbers out front, so we're just going to multiply everything underneath. 14x times 2x is going to give me 28x squared. So now we're going to go ahead and we're going to simplify anything we possibly can. 14, can I simplify 14? Well, let's see it. My perfect squares, I don't have anything that goes into 14. And then if I go in, can I simplify that x under the radical? Well, it needs a partner so it can come out. So in this situation, I can't simplify anything for that first part. The 3 root 14 is going to stay. Now, we're going to try to simplify the 28. So when I think of this, I can write this as the square root of 4 and the square root of 7. I'm going to rewrite my x squared as x times x. So we still have 3 root 14x. Step by step here. Square root of 4 is 2. And then I know that this x times x, since there's a partner, they can come out. So that's going to actually be out here as 1. And then root 7 is going to be a decimal, so I'm going to leave that. When adding and subtracting, things under the root have to be the same. They are not in this case, so I can't put them together. So that's my final answer. I want you to pause the video and try number 10 on your own. It is just distributive property with no variables. So pause it, try it, and then come back and check your answers. So I went through and multiplied, and then I simplified my root 40 into root 4 and root 10. When you do that, you get all the way down here, and you have things underneath the radical that are the same. So you can go ahead and you can actually do that subtraction. So 5 minus 8 gave me the negative 3 root 10 as my answer. If you didn't get that, please come check with me before moving on the notes here. Our last two examples here, we want to think back to multiple units ago when we used our box method. You either used box or you used FOIL. You did your first times your outsides, insides, and lasts. I like the box method because it keeps things a little bit more organized for me. So with the box method, it said that we write each factor on the outside. So I had 3 plus root 5 and then 3 minus root 5. So we multiply the outsides to get the insides. So when I do 3 times root 5, I get 3 root 5. When I do root 5 times negative root 5, you multiply the things underneath. So I'm going to get negative root 25. 3 times 3 is going to give me 9. And 3 times negative root 5 gives me negative 3 root 5. So we want to add our insides, so I'm going to have 9 plus 3 root 5 minus 3 root 5 minus 25, root 25. So simplify anything you possibly can. Well, I know that 3 root 5 minus 3 root 5, these are going to cancel each other out. So I'm going to be left with 9 minus square root of 25. Looking at simplifying square root of 25, I know that that's 5. So I'm going to end up with 9 minus 5 then. So my final answer is going to be 4. Number 12 here, again, we're going to use our box just because it keeps things a little bit more organized for me. So I'm going to have root 6 plus root 8, and then I'll have root 24 plus root 2. So we're going to multiply underneath. So I'm going to do root 24 times root 6. I'm going to get square root of 144. Root 24 times root 8 is going to give me square root of 192. Square root of 8 times square root of 2 gives me square root of 16. Square root of 6 times square root of 2 gives me square root of 12. So we're going to add all of our insides together. So I'm going to have square root of 144 plus square root of 192 plus square root of 12 plus square root of 16. Now this is going to be a little long problem here because we want to simplify anything we can. I know the square root of 144 is just 12. I'm going to simplify the square root of 192. I know 64 is one of those perfect squares that goes into 192, and it's 64 times 3. 12, I'm going to simplify into square root of 4, square root of 3. And I know 16, square root of 16 is just 4. So we're going to go even further here. I'm going to have 12 plus square root of 64 is 8 root 3. Square root of 4 is 2. And then I still have the root 3 plus 4. So we're going to put like terms together now. 12 and 4 is going to give me the 16. And since these both have root 3's under them, I can put them together. So 8 and 2 gives me plus 10 root 3. And that's going to be my final answer. So on to the practice for you guys. If you have any questions, come chat with me.